Let's solve this problem. Find and classify all of the stationary points of the function of xy equals xy squared plus y minus x. Okay? So, if this was a problem in an exam, remember, you can consult with the given equations so you know the steps that you need to follow. So first, find the stationary points, and second, you classify them. Okay? So the first step involves calculating the first order partial derivatives and equating to 0, and the second step involves calculating the second order partial derivatives, then calculating this term here and checking its sign. Okay? So let's start on the first step. First, find the stationary points. So we need to calculate the first order partial derivatives. So let's do it. Partial of f with respect to x equals. So we need to do the derivative of this with respect to x, imagining that y is a constant. This is very easy. This is going to be y squared plus 0 minus 1. Okay? And the partial of f with respect to y, we have to do the derivative of this with respect to y, imagining that x is a constant. So that will be 2xy plus 1 minus 0. Okay, those are the first order partial derivatives. We need to equate both of them to 0. Okay, and now we need to find the solutions to these two equations simultaneously. That is very important. Okay, so let's call it, the two conditions are 1 and 2. So let's try to find when both 1 and 2 are true. Okay, so let me write this down. Stationary points equals when 1 and 2 are true simultaneously. Okay, so we need to solve them simultaneously. So first, from 1, it's actually pretty easy to see that the solutions to 1 are that y is plus 1 or minus 1. So we have y equals 1 or y equals minus 1. Okay, so let's call this 1a and 1b. Okay, and if we substitute this into 2, we need to check both possibilities, right? Because now, in some sense, we know that condition 1 is true if 1a is true or if 1b is true. Either of them can be true. Okay, which means that we have to do 1a or 1b must be true. One of the two must be true, and 2 still has to be true. Yeah. So following this logic, this means that we have to check if 1a and 2 are true. So that will be one possibility, or it could also be that 1b and 2 are true. This is another possibility. Okay, so let's check the first possibility when 1a and 2 are true. So y equals 1 is 1a, and we substitute it into 2, and we find 2x, or let me write it here. So this leads to 2xy, which is 1 plus 1 equals 0, which leads to x equals minus a half. Okay, and y equals 1. Remember, we substituted y equals 1. While the other possibility is that 1b is true, so y equals minus 1, and at the same time 2 must be true. So 2xy, that's minus 2x, plus 1 equals 0. So we substitute this and we find that x equals 1/2. Okay, so we found two stationary points. So the two stationary points are xy equals minus 1/2 1, or xy equals 1/2 minus 1. These are the two stationary points for this problem. Okay? Next, the second step is to classify them. So in order to classify them, we need to calculate this. And in order to calculate this, we need to calculate the second order partial derivatives. So let's do it. Second order partial derivatives. So fxx, this is going to be the partial with respect to x of the first order partial derivative, which is this one, y squared minus 1. And this is actually equal to 0 because there are no x's involved. Then fyy is the partial with respect to y of the partial with respect to y, which is this. So I substitute this here, 2xy plus 1. So what's the partial with respect to y of this? It's equal to 2x plus 0. Yeah. And now finally f of xy, which is the same as f of yx, as we know. So this is going to be the derivative with respect to y of the partial with respect to x, which is this, y squared minus 1. So we get 2y. Okay, so those are our three second order partial derivatives. Actually, as you know, they are 4, but these two are equal, so you don't need to calculate them. But we could if we wanted, yeah? Okay, so now we have them. So now what is the sign? So now check the sign of the term fxx times fyy minus fxy squared, which is given, yeah? This is always given. Check the sign of this at each stationary point. So what does this mean? This means that I need to substitute the values xy of the point. I need to substitute it into the second order partial derivative. So wherever there is an x, I substitute the x, and wherever there is a y, I substitute the y. Yeah. So for first point, which is xy equals minus a half 1. So I do that. So then fxx is 0, fyy is 2x, which is 2 times minus a half, that's minus 1, and fxy equals 2y, which is 2. And therefore, fxx times fyy minus fxy squared is equal to 0 minus 2 squared, which is minus 4, which is negative. Okay, so when this term is negative, we know that this is a saddle point. So therefore, minus a half 1 is a saddle point. Okay, that was for the first stationary point. Now let's repeat the calculation for the second stationary point. So for xy equals 1/2 1, so we substitute x equals 1/2 and y equals minus 1, not 1. So we need to substitute x equals 1/2 and y equals minus 1 into the second order partial derivatives, and we get that fxx equals 0, fyy equals 2x, which is 1, and fxy equals 2y, which is minus 2. So now we calculate the term fxx times fyy minus fxy squared, which is equal to 0 minus 2 squared, which is equal to 0 minus 4 minus 4, which is negative. And therefore, because this term is negative, this means that the point 1/2 minus 1 is a saddle point. And with this, we have finished our problem. For your curiosity, I have actually plotted this function, and you can see that indeed the 2 points are stationary points, and they are both a saddle point. So this point, which corresponds to x equals 1/2 and y equals -1. So you can see that the gradient, or it looks like a local minimum in this direction, but it looks like a local maximum in the other direction. So it is a saddle point. And similarly for the other point. Okay? Excellent. So you can see that it's quite easy to find stationary points and classify them. You have plenty of problems in the PDF of the notes, so I recommend you to go through more problems. The only 2 tricky parts I would tell you to look out for is, first, when you are solving the simultaneous equations, you must make sure that both equations are true. Both. So that's why I insisted on this "and" here. Okay? But sometimes one of the equations splits into 2. So you have either this or this, which means that the condition 1 splits into 2 possible conditions, this or this. And therefore, you need to check if this and this is true. Don't forget about this. And then check if this and this is true. Okay. Sometimes in other exercises, the condition 2 also splits into 2 conditions, this or this. So then you would have to check 4 different combinations. Okay. So the main point is to make sure that both are true at the same time. The best way to make sure that the solutions you get are correct is to substitute them back in and check if both equations are equal to 0. Okay, that's the first tricky part. A second tricky part I see some students making the mistake is, after you calculate the first order partial derivatives and you find the points, do not substitute the value for x and y into the first order before you calculate the second order partial derivatives. That would be a mistake. Okay, you need to leave the first order partial derivative as functions of x and y in order to be able to find the second order partial derivatives, which are also functions of x and y in general. And only after you have done the derivative, now you can substitute the value for x and y that corresponds to the different points. Okay? So with that, we can end it here. Thank you very much for listening, and see you in the next video.